This video lecture contain question number 3C. Question 3C. Find radius and interval of convergence of the power series. Summation n is 0 to infinity and x raised to n upon 2 raised to n. So now first let's understand the question. This one is a sum of power series. Okay. So first of all, what is the general form of power series? Series an x minus c raised to n. Now compare with this. So what is an here? An is n upon 2 raised to n, and here what is c? C equal to 0. Okay. So this is the power series. Now the question is to find radius and interval of convergence. मतलब कि हमें यहाँ पे एक इंटरवल फाइंड करना है जिसके हर एक पॉइंट पे ये सीरीज क्या है, कन्वर्जेंट है. ओके. और ये इंटरवल का हमें क्या फाइंड करना है, लेंथ. सो दिस लेंथ इज नथिंग बट रेडियस ऑफ कन्वर्जेंस. ओके. एंड दिस इंटरवल इज नोन एज इंटरवल ऑफ कन्वर्जेंस. टू अंडरस्टैंड द concept of power series, you can refer this link. In this video lecture, the entire power series and the concept of radius and interval of convergence is given. Okay, so before solving this example, I prefer to refer this video. Okay, now let's start. The given power series is n x raised to n upon 2 raised to n, where un is equal to n x raised to n upon 2 raised to n. Now here understand the difference between un and an. Okay, here an is what? An is a coefficient of this x minus c term. Okay, so an is n upon 2 raised to n. This an is free from x. But here what is un? Un is the nth term of this series. Okay, nth term of this series. So un is what? N x raised to n upon 2 raised to n. Now to find the radius of convergence and interval of convergence, use ratio test. So L equal to limit n tends to infinity absolute of un plus 1 upon un. Here un is nth number of term and un plus 1 is what? Un plus 1 is n plus 1th number of term. Okay. So how to find un plus 1? In un, n is replaced by what? N is replaced by n plus 1. Okay. So now here n is replaced by n plus 1. So what we get? Here we get n plus 1 x raised to n plus 1 upon 2 raised to n plus 1. Okay. Now the entire term is divided by un. So what is un? Un is n x raised to n upon 2 raised to n. Okay. Now here take the absolute value. Now take this denominator into numerator. So we get this form n plus 1 x raised to n plus 1 upon 2 raised to n plus 1 into shift this denominator into numerator. So 2 raised to n upon n x raised to n. Now here what we get? N plus 1 x raised to n plus 1. Can we write x raised to n into x into 2 raised to n upon 2 raised to n into 2 into n x raised to n. Okay. So here 2 raised to n is cancel out. Again x raised to n is cancel out. Okay. So what we get? N tends to infinity n plus 1 x upon 2n. Now from this take n common. Okay. So limit n tends to infinity, n is common, so 1 plus 1 upon n into x upon 2n. Now apply limit. So here n is cancel out. Apply limit. So this 1 upon n become what? 0. So what we get? We get mod x by mod 2, but 2 is a positive number, so that's why 2 is free from absolute value. Okay, so this is my L. L is what? Mod x by 2. Now, according to ratio test, what is the condition of convergence? When we say that the given series is convergent, if L is less than 1. Okay, so for this, refer the ratio test. If L is less than 1, then what we conclude? The given series is convergent series. Okay, so that's why here we are interested to find the interval of convergence. Okay, so that's why here we take mod x by 2 is less than 1. Okay, now to shift this side, so mod x is less than 2. So this one is nothing but my capital R, and capital R is what? Capital R is radius of convergence. Okay, now simplify this. So what we get? Mod x less than 2 means this is the minus 2 less than x less than 2. Okay, so this is what? This is the interval of convergence. The value of x for which the given power series is convergent is lie in this interval minus 2 to 2. Okay, so the hence radius of convergence is r equal to 2 and interval of convergence is open interval minus 2 to 2. Okay, now the next is we are interested to check the given series is convergent at the end point or not. Okay, मतलब कि हमें ये end point पे check करना है x इक्वल टू -2 पे सीरीज कन्वर्जेंट है या नहीं और 2 पे सीरीज कन्वर्जेंट है या नहीं. ओके, अगर ये एंड पॉइंट पे भी सीरीज कन्वर्जेंट होगी तो हम कैसे लिख सकते हैं? क्लोज इंटरवल -2 to 2. ओके, सो नाउ लेट्स स्टार्ट. नाउ चेक कन्वर्जेंस एट एंड पॉइंट्स फॉर x इक्वल टू 2. नाउ व्हाट इज अवर गिवन सीरीज? व्हाट इज द सीरीज? Series is n x raised to n upon 2 raised to n. Okay, this is the given series. Now in given series put x equal to 2 because here we are checking convergence for x equal to 2. So that's why in this series put x equal to 2. So what we get? N 2 raised to n upon 2 raised to n. So now this 2 raised to n is cancelled out. The series is what? N. Okay, so now for x equal to 2 we get a series n equal to 0 to infinity n. This is my series. Now check the convergence of this series. So for this what we use? We use nth term test. Okay, as we discussed earlier. And what is the nth term test? According to nth term test, if limit n tends to infinity an is not equal to 0, then what we conclude? The given series is divergent series. Okay, so now let's start. Take limit n tends to infinity. What is the nth term? Nth term is nothing but n. Apply limit, so n is infinity, we get the answer infinity, and infinity is not equal to 0. Okay, so from these what we conclude? The given series is divergent series. So at x equal to 2 point the given series is what? Divergent. So that's why 2 point is not included in the interval. Okay, so at 2 we keep the open interval. Okay, now let's check for x equal to -2. Again same procedure. In the given series put x equal to -2. Okay, now simplify this. -2 raised to n. So can we write -1 raised to n into 2 raised to n? Say yes or no. Okay, so that's why 2 raised to n, 2 raised to n is cancelled out. What we have? N minus 1 raised to n. Okay, so this is my new series for x equal to -2. Now let's check the convergence of this series. Now first observe here, this series is what? Alternating series, because here -1 raised to n is given. What is the general form of alternating series? an minus 1 raised to n. Okay, so this is my alternating series, and what is an? An is equal to n. Okay, so now to find the convergence of alternating series, only Leibniz test is applicable. Okay, so first we start with the Leibniz test. if Leibniz test is not applicable, then we think for the other test. Okay, तो चलो फर्स्ट हम Leibniz test देखते हैं. According to the Leibniz test, the alternating series converges if the following conditions are satisfied. First condition, each term is numerically less than its preceding term. That is, mod an plus 1 is less than an for all n. मतलब कि हर एक टर्म क्या होनी चाहिए, उसकी प्रीवियस टर्म से लेस होनी चाहिए. मतलब कि ये सीरीज क्या है, डिक्रीजिंग होनी चाहिए. बराबर है. अगर ये डिक्रीजिंग है तभी हमें क्या करना है, ये सेकंड चेक करना है. बराबर है. सेकंड कंडीशन क्या है, लिमिट n टेंड्स टू इंफिनिटी an इक्वल टू 0. ओके, इफ दीज टू कंडीशंस आर सेटिस्फाइड, देन व्हाट वी कंक्लूड, द गिवन अल्टरनेटिंग सीरीज इज कन्वर्जेंट सीरीज. क्लियर? So now let's start. Now here, what is my an? An is equal to n. Okay. So what is an plus 1? An plus 1 is n plus 1. So obviously here mod an plus 1 is greater than mod an for all n. Say yes or no. तो ये सीरीज क्या है? Which shows that an is increasing, not decreasing. मतलब कि ये सीरीज क्या हो रही है, हमारी an टर्म क्या है, an हमारे पास n टर्म है, और an प्लस 1 टर्म क्या हो गई, यहाँ पे an प्लस 1 हो गई हमारे पास n प्लस 1 टर्म. ओके, मतलब कि यहाँ पे ये टर्म क्या है, प्रीवियस टर्म से ग्रेटर है. मतलब कि ये सीरीज क्या है, इंक्रीजिंग सीरीज है. ओके, सो दैट्स व्हाई हैंस द फर्स्ट कंडीशन ऑफ द लिबनिज टेस्ट इज नॉट सेटिस्फाइड. ओके, फर्स्ट कंडीशन ही सेटिस्फाइड नहीं हो रही है तो हम यहाँ पे लिबनिज टेस्ट अप्लाई नहीं कर सकते. So therefore the Leibniz test is not applicable. So now to check the convergence of this series, apply other test. Okay, तो हम यहाँ पे क्या यूज करेंगे, apply nth term test of divergence. So as we discussed earlier, limit n tends to infinity an. तो यहाँ पे an क्या है मेरे पास, nth number of term हमें यहाँ पे लेना है. Okay, तो limit n tends to infinity n minus 1 raised to n. Limit n tends to infinity n minus 1 raised to n. Okay, so what we get here, we get limit n tends to infinity either plus n or minus n. It's depend on whether n is even or odd. Okay, अगर n even है तो हमें क्या मिलेगा, ये n मिलेगा, और अगर n odd है तो ये नेगेटिव हो जाएगा for odd n. Okay, now apply the limit. So what we get, my answer is either plus infinity or minus infinity. Say yes or no. Okay, so that's why this one is not equal to 0. So that's why here what we conclude, the given series is a divergent series. Okay, मतलब के x इक्वल टू माइनस 2 पॉइंट पे भी क्या है, सीरीज डाइवर्जेंट है. ओके, मतलब कि हमें माइनस 2 पॉइंट भी क्या करना है, इंक्लूड नहीं करना है. ओके, सो दैट्स व्हाई what is the conclusion, radius of convergence r is 2 and interval of convergence is open interval minus 2 to 2. Clear?